This video is part 5 in a 6-part series on matrix math. None of these videos are for any particular program. This part is covering the two topics of transpose and determinant. To transpose a matrix is to essentially flip it. For example, if we want to transpose matrix A, then what we have to do is make every single row a column and every column a row. So if the first column is 3, 9, that means the new first row is 3, 9. Second column is 4, 7 becomes the second row, and then 2, 3 becomes the final row. It has the ability to turn a row vector into a column vector. 6, 5, 2, 7, 8, 1, 15. It's very simple, but it's easy to forget what that T means. If all we knew is that A equals this matrix, and we're given a homework assignment to give 1 of A to the T, that means we're asked for the transpose of matrix A. So A to the T equals the matrix we created a moment ago. The determinant is a little bit different. The determinant of a matrix is a single numerical value that represents the value of the whole matrix. It has many different uses. For example, it can tell you if a matrix is singular, and if a matrix is singular, that means it cannot be inverted. Or it can tell you if the formulas or equations corresponding to a given matrix have a unique single value. To calculate the determinant, you have to combine all the numbers into one value. To practice, we're going to use a 2 by 2 matrix. So our 2 by 2 matrix C is given here. Having the C with these straight lines next to it means to find the determinant of it rather than to find the absolute value. So to find the determinant of C, we first have to multiply all the numbers in this direction, so 3 times 7, and subtract the numbers going in the other direction, minus 4 times 9, and that equals negative 17. So the determinant of C is negative 17. It gets much more complicated, however, when you work with a larger matrix. So this matrix, matrix D, is more general. We're not actually going to use numbers. Since it's a 3 by 3 matrix instead of a 2 by 2 matrix, we have to go in this direction 3 times. To make this slightly easier, what I like to do is to add 2 more columns to the side that just repeat the first 2 columns. Now what I do is I go in one direction all the way first. So A, E, I all multiplied together, and then add to it the next diagonal, B, F, G, and add to it the third diagonal of C, D, H, then subtract C, E, G, subtract A, F, H, and subtract B, D, I. And the number that this returns is your determinant. If the determinant equals 0, that means that there is no unique solution and the matrix is a singular matrix. Calculating a determinant by hand can get extremely complicated extremely quickly. For example, our first matrix was a 2 by 2 matrix, so it's a 2 by 2 square matrix. The number of things we had to multiply is 2 factorial, which is 2 times 1, and that comes to 1 and 2. When we hit a 3 by 3 matrix, that's 3 factorial. 3 times 2 times 1. 1, 2, 3, 4, 5, and 6. If you have a 4 by 4 matrix, then you have to calculate 24 different diagonals. A 5 by 5, and that goes up to 120. Luckily, in both Excel and MATLAB, you have the ability to calculate the determinant by telling the program to do it for you. So you don't have to worry about calculating 120 diagonals. You can just tell the program to give you the determinant of a function.